All right, well, good afternoon, you wonderful people. Let's go ahead and get started with the lesson for today. Moving over to there. So we're gonna start the new unit on functions. So we'll start out with linear functions. So let me go ahead and go over to the, see that one here. So objectives for today. Identify if a given equation is a function or not. Find the domain and range of a function, rewrite function notation, and evaluate functions with given inputs. All right, so this is the first page of the packet. So going through your packets, if you remember, what was it, the 11th or so, there was a packet that had this on there. So if you didn't do that, that's fine because we're going over it now. So be working in your week 6 packet. If you did not finish your week 5 packet, this would have been the last thing that we would have done. So don't worry about that. But again, I'll give you some more information when that quiz becomes available. The quiz on the Schoology is having problems. I think most students are able to log on. They just can't get the quiz itself open. And I've like I said, I've checked everything and it should be fine. I don't know what's going on, but I'll keep you posted. Anyway, so a set of ordered pairs can be shown in a table, a mapping diagram, a graph, or expressed as an equation. So those are the different ways that we can put together a ordered pair or a function. So function is basically just anything that has an input and an output, but I'll get to more of that later. But basically there is an X and a Y value that happen. And again, you can put them in these 4 methods here. And since I was talking about X's and Y's, the X value is called the domain. So those are all of the possible values that you can put in for X so that you get a value of Y, which we call the range. And again, more on that later. A relation with distinct points is called discrete. Okay, that doesn't mean secret discrete. That means more like it has to be one or the other. Okay. To describe a discrete number, I usually use the example of a dice. So we've all played with dices or number cubes with numbers 1 through 6 on them. If you were playing with a dice, is it possible to roll a 4.5? No, you can't roll a 4.5 on a dice because there's only 1, 2, 3, 4, 5, and 6. Those are your only options. Another example for discrete would be like buying something. So if you were to go to a restaurant and order something from the dollar menu, you cannot buy half a hamburger. So you can only buy them in full numbers, in whole numbers. So you cannot buy like 4.5 hot and spicy McChickens. That's an example of a discrete function. The other one is continuous. So it's usually a line or a curve. And continuous it means all numbers in between. So you could pick something like 3.2 or 4.5, and you have pretty much all the values available. So I'll talk some more about these when we see some examples on what some of these are. But these are the, again, basic types of relations in functions. So let's go ahead and talk about the functions. So these blue parts are written, those are not on the packet, so you are gonna have to write those in yourself. So the relation in which each element of the domain is paired with exactly one element of the range. Okay, yeah, that is the definition, but I think maybe it'd be easier just to remember the kind of easier way of doing this, and that is to not have any X values repeat. So again, each one of these is an input and an output, so an X and a Y value. So this is your input. And thinking back to that buying hamburgers, I ask the teller, or the cashier, sorry, the teller, like it's a bank. But I'll ask the cashier, can I have 4 hamburgers? And they will tell me what to pay. that is the output. So if I want 4 hot and spicy McChickens, that's going to be about $3.32. All right, I don't get to choose what to pay. And with this function, why it has exactly one element of domain with one element of range is because I want you to imagine that you've been buying hot and spicy McChickens for all week, okay? You go there, you want 3 hot and spicies, $3.24. You go back there for lunch the next day. You want 3 hot and spicies, they tell you $3.24. And you do this day after day after day until one day you go there and you say, I want 3 hot and spicy McChickens, and they say $7.56. And you're like, what? Now you see that the input gets a different output. So that's one way of thinking about it, is it's like a price that doesn't really make sense. Because there's no way you would have to pay 2 different prices for the same thing. Maybe they changed their prices, I don't know. But assuming it's just a regular day, okay, so there's no great chicken shortage or anything like that. So let's go ahead and look through these and see if there are any functions. So this first set of ordered pairs is a function because if we look at the x values, we have 0, -5, 6, and +5, or just 5. Now in this case, each x value is unique. None of them repeat themselves. So yes, this one is a function. And I'll talk about more of these later, but let's do this one here with not a function. So this one is not a function because I have -7, 6, 6, and -3. So again, it's like if I asked, you know, can I have 6 hot and spicies, and they tell me one price, and then the next day, or maybe the car behind me asks for 6 and they get charged a different price, you know, that doesn't happen. Your inputs and outputs should always be unique. So in this case, this is not a function because it repeats the x number. And again, the x number is the first one. And there's another thing you can do, and that is called the vertical line test. So vertical line test is, imagine you have a vertical line. Well, in this case, you don't have to imagine because you can see mine, and I can kind of move it side to side. So in order for a function to be a function, the vertical line cannot pass through more than one point in the relation. So if you imagine, so you're going to have to imagine it yourself on some of these, or you could use a ruler or something. But if I'm moving this line from left to right, you'll notice that when it meets the line, in this case, there is one spot that it meets, okay? And you can see that the spot where they meet is going up and up as I move to the right, but it never touches more than once. And since this line goes on in both directions for infinity, it's safe to assume that it will never connect or intersect more than once. And in this case here, I have an example of something that is not a function. Now, as I move my line to the left, I run into a point here. So this would work out because I only have one point that it can meet up at. But as I move further down, now I have 2 spots. I have an upper and a lower intersection. In this case, it's not a function, okay? Because again, if you wanted a hot and spicy McChicken and they told you it's gonna be -$1.08, which never happens, by the way. But again, the prices are fixed usually, and there's no way it's going to work out where you get 2 different prices for the same object, same item. So in that case, this one fails the vertical line test, so it's not a function. And just as an example too, just to kind of show here, like let's say I pick x is equal to, let's just say this is 2. All right, now we don't need to be specific, but I would have x over 2 up 4 and over 2 down 4. All right, so I have the same input, which is 2, and I get -4 and +4. So in that case, that's not a function because the x value repeats itself. In this case, it was -2 in my example. All right, so let's go ahead and work on some more, domain and ranges. So find the domain and range of each relation, then determine if the relation is a function. All right, so they give us ordered pairs here. So again, ordered pairs is a spot on the graph. So in this case, it would be back 1, down 9 on the graph, but we don't need to really know that too much. So let's go ahead and I'm going to put the domain here. So for the domain, I'm going to start out with the lowest numbers and work my way to the greater numbers. So in this case here, the lowest number seems to be -1, and then 0, and then 4, and then 6. And then again, I'm going to put them in ascending order, or again, from lowest to greatest. And I notice that none of them repeat themselves. I don't have 2 of the same number at all. Make that a little bit smaller so I know it'll fit in other lines. And then I'm going to go ahead and do the relation. And I'm going to put this brace on there. It's that kind of squiggly parenthesis looking thing. That means it's a set. So that means the set of all range numbers. So I'm going to go ahead and start putting these in there. So I'm looking at the y value. So the y value is the second number in each pair. So for the first one, it would be -9, -5. And you might think the next one is 3, but again, we've got to put them in order to the greatest number. So as we go up, we need to increase the number. -5, -2, and 3 are the rest of the numbers. And in this case, I have 4 elements of domain and 4 elements of the range. Since none of the x numbers repeat themselves, this one will be, yes, it is a function. See, not too bad. Let's go ahead and work on the next one. So number 2, starting with the lowest number, the least value number, I'm gonna -3, and then it looks like we have 5, and I can't see what that last number is. Is it 8? I think it's an 8. Oops, wrong type of grouping symbol. And there we go. We have 3 distinct elements of the domain. And time for the range. And again, look around for the lowest number. So in this case, it would be -6, even though it's the third, it's out of the third set. We're looking at the lowest numbers. And then 0. Oopsie, I said 0. Must have not pushed the button down all the way. 2, and then 4, and then close the set. So we're complete with the set of all range numbers from here. Okay, and now we need to answer the question of whether it is a function or not. So in this case here, if you are paying attention, you'll notice that the 5 repeats itself. So I have the same input, but 2 different output, 2 different results. So in this case here, that's going to be a no. It is not a function because it doesn't quite work out. Since the x value repeats itself, that's not a function. All right, and now let's go ahead and use a table. So that's one way to show a function or a relation is ordered pairs, and the other way was a table. So for this one here, the table shows a list of x values and the corresponding y values to each of those x values. So this is like an ordered pair. It's just like 7, -8, you know, like in parentheses. Next one would be 2 parentheses, 2, 3. Next parenthesis is 0, -1, and so on. Now in this one here, it looks like it's already in numerical order. I'm going to just start calling that numerical order. Kind of like alphabetical order, but with numbers instead. Okay, there we go. And let's go ahead and list out the y values. And again, I'm going to put them in order. So set of -1, 3, and it looks like we already have a repeat. So in this case, we have a repeat with 3 in the range. And the question is, will it be a function or not a function? Now remember, the rules say that it can't have x values that repeat. It says nothing about y, so y values can repeat themselves. Okay, it's only the x ones that cannot repeat themselves. So in this case, none of the x values repeat themselves. So therefore, this indeed is a function. So yes, it's a function. Domain. Okay, so again, start with, now this one already looks like it's in numerical order. So I'm going to go ahead and just start putting the numbers in there, 10, 15. Come on, 10, 15, 18, and 24. Okay, that worked out. And then the range, and again, starting from the lowest number, that would be 0, 3, 7, 11. Oopsie. There we go. And now we look it over, and in this case, we have 4 elements of the domain and 4 distinct elements of the range. So this will indeed be a function. So yes, it is a function. And there you go. That's it with all of those. So we got ordered pairs and tables. The next type of relation method is going to be mapping. So if you remember back when we were talking about what you need to know for this lesson, the next one was mapping. So mapping is kind of like a table. It's kind of like a table in that there is, it's showing you a way that the domain and range fit together, the x and the y go together. So in this case here, I have an ordered pair of -4, 0, -2 and 3, 5 and 7, and 5 and 9. So the ordered pairs go with the arrows that they're in. So the arrows do make a difference. But in this case here, we can see that there are fewer elements of the x than there are of the y's. So let's go ahead and list them out. So my domain, starting from the lowest, is going to be -4, -2, and 5. Now time for the y's. So again, open the set. 0, 3, 7, and 9. Now, the next question is this a function or not a function? So again, thinking of it as ordered pairs, I have the last 2 are 5, 7, and 5, 9. Since they both share that x, and you can also see it in the mapping diagram, it shows you the relation a little bit better. 5 and 7 and 9, you know, I can easily see that the 5 is being shared. So the 5 is being shared, so that means that it is not a function. All right, and with this one here, number 6, let's go ahead and start putting it. Now again, it puts it in numerical order already. So with the x values, and any mapping diagram for that matter, they will mostly be in numerical order. Well, they have to be in order to be part of the mapping diagram. But you never know. Sometimes some textbooks will forget those things. They will forget to put those numbers in there. in order, which they're supposed to be. All right, so on to well, we're still on the same problem, but we're just working on the y now. So we'll look at the range. And again, starting from the lowest, -4, 0, and 7. Now in this case here, I can see that the 7 is being shared right here. So the 7 is being shared. But again, the y values, they can repeat themselves. They can share the same number. Okay, so it's kind of like, well, I don't know if it's a problem at this school, but it's one of those things where one group can do something and the other group can't. Like, boys can wear the same pants all week and nobody says anything. I'm kidding. Anyway, let's go ahead and answer if this is a function. But thinking about it, I could probably wear the same pants and no one would ever notice. In fact, I could probably be wearing board shorts right now and nobody would notice. In fact, why don't I? Anyway, function, is it a function? Again, yes, because y's can repeat themselves, x's cannot. And there we go. What was after mapping? Let's see, mapping was this one. I think we're gonna go graphing now. So I did mention that I was gonna point out some of the examples as we cover them about discrete and continuous. So before we even start working on this one, I wanna point out that these lines are discrete and continuous. The first one, number 7, is discrete because each dot, if I were to imagine an area, so going through here, all right, I can only pick x values at this number, this number, this number, which is 2, and this number, which is 4. So those are the only values I pick. If I pick something like here at -1, x at -1, I don't get anything back. I don't get anything returned to me. So this is a discrete graph. So for a discrete graph, I can just name out the numbers. So the first number in my discrete domain is going to be -3, 0, 2, and 4. So those are the numbers that I can pick in that relation. Now to get the next one, which is the range, I'm going to make a horizontal line. Now there is no such thing as horizontal line test, but I'm just doing this to show you. Oopsie. There we go, move that one. So what you would do is you'd imagine a line coming from the bottom and picking the first one. So in this case, it would be -5, -2, and I'm counting the y-axis, which is the up and down one, -1, +1, and 4. So those are the two numbers that I can pick. I'm sorry, not two numbers, there's actually several of them. But those are the numbers that I can pick for the y. So again, set -5, and then -2, -1, 0, 1, and 4. Okay, there is none at 0. I knew there's one extra somewhere. Okay, there we go. That's all the value of the ranges I can pick. So I cannot pick anything in between any of those numbers. Those are all I have. So is this a function? Well, again, if you have a graph, you can use vertical line test. And if I put it right here, I end up with 2 lines passing my vertical line, 2 points passing my vertical line. So in this case here, it fails, which means it's a no, it is not a function. All right, domain for this one here. Now this one is continuous. So if I wanted to pick a spot like x equals 1.5, so I go over 1.5 and I have to go to the line, and it would be up 1.75, I'm guessing. I can pick that. I can pick all of these numbers between here and there. So there are all those numbers that I can pick. Since I can pick anything in there, the domain is all real numbers. I can't spell out numbers, so all real, this thing here, the pound sign. Okay, that's not hashtag. It's pound. Oh gosh, it had it means pound, but it also means number. But it had a name. I forget its name. Anyway, so that that line goes sideways forever in both directions. So it doesn't just stop. Okay, it goes on and on forever in both directions, but it also goes forever in up and down direction also. So if I go down, there's going to be a point on the graph that I'll be able to meet up with. If I go up, you know, there's another part of the function, the line, I will be able to meet up with. So in this case, this one also is all real numbers. So I can pick any number and get any number back out. And again, it can be decimals, it can be fractions, anything really. But is it a function? So let's go ahead and grab our vertical line. Again, you'll have to just do your imagination or maybe a ruler or something. But if I start from this side and I pass my vertical line over this line, I never meet more than once. Since I don't have any repeat of any values, really, it's gonna be a definite yes. Definitely yes for that one. There we go. Okay. Moving on to the next one, we have different kinds of graphs going on here. So for that first one, number 9, it looks like we have a piecewise graph where we have two separate lines together and they kind of end at certain points. So let's go ahead and go through this and identify the domain. So x values. Now I'm going to go back to that last one really quick just because I want this line again. So cut and paste. So I'm going to paste that line here. So this line here shall tell me all of my domains. So if I start from here, nothing, 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 and I get something right there. Those lines are what I'm looking for. So I get something right there. So that means my domain, oopsie, my domain, let me try seeing if I can type this here, are x numbers, x values, greater than, because the x would have to be greater than -4. So anything greater than -4 is going to work out. Greater than or equal to -4. Because if I keep going this way, I do get x values. So if I like say pick x of -3, I get two outputs. I get one that looks like it's about y2 and another that's about -1.5 or something like that. Probably like -1.3 or something is my guess. But that's not important right now. The thing is we get two numbers meeting here. So there we go. Now for this next one here, we're going to use the same thing and we're going to imagine the range. So the range for this one here, imagine that line from the bottom going up, 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 up. But if you look at the lines are pointing down and up. And that arrowhead means that it goes on in both directions, up and down, infinity. So even if I go down to like 5,000 or something, I'll still get a number along the line that matches up with there. And same thing, if I go up to 1,000,000, I will still get a number that reaches my line. So in this case, we have all real numbers again. To make it easier to read, I'll just say all reals. And is this a function? Well, if you remember when I passed the vertical line through it, there were several places where I had two x values that matched. Like here in my example, I picked -3 and I had 1.5 and -1.3. So this is going to be no, not a function. Now this next one's a little bit of a tricky one too, because we haven't really seen anything. And these functions can be anything. They can be circle functions or hyperbolas, parabolas. And there's a lot of other ones. I just don't, I probably could remember all of them, but there are plenty of them. Okay, so again, nothing, 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 but when I get to here, I do get a value. So x, anything x greater than -2 or equal to, and I end up with more area here. And if I get to this side here, that's the highest value I can pick, because after this, there's nothing else. So I'm going to need a between statement for this one. And we already worked on inequalities with between statements, which is why you need to pay attention in class, because the things you learn are going to come back later, right? Everything's going to come back later, because everything we learn is used in other things that you will learn. So for this one here, like I said, -2, and -2 has got to be less than x. If you read it backwards, starting from the right and read left, it says x is greater than or equal to -2. All right, but again, this is a between statement, so x has to be between -2 and, in this case, 5, I think. I think that's what I said. I think I said 5. Now I can't write an or equal to symbol here. So since I can't write the or equal to symbol, I just drew them in there. All right, and now for this next one here, doing the range. So again, imagine that vertical, horizontal line coming from the bottom, and find the first number that you get as a y value, which in this case is going to be also -2. But x is going to have to be greater than that. So you could either say x is greater than -2 or -2 is less than x. Both mean the same thing, just, I guess, different direction, but the same thing. Again, that's like saying my older brother is older than me, or I am younger than my older brother. And the highest value of this one is 4, because it doesn't quite get to 5. But we do have 4, so there we go. Is this one a function? Again, passing my vertical line, if I go anywhere in that line, I meet the circle in 2 places, above and below. So 1 cross, 2 cross. Since it intersects those lines, it's going to be a negative on that. No, it is not a function. Again, functions have inputs and outputs that are supposed to be different. They're supposed to be unique in their x value. Okay, so for this next part here, it looks like we're going to need a calculator, which okay, so if you were in the class, you would have calculators available to you and you could just graph them. But if you're watching this video, that means you're either watching it on YouTube or you're here in the Zoom meeting with me, which obviously if you're here, you know which one that is. But if you have access to the internet, you're going to need to use the internet to work on some of these, because there's a really good graphing tool that we're going to be using in this lesson here. So the first one is going to be, let me show you how we get there. So let's see, I'm at my Zoom meeting now, and I'm going to go open a new tab, and you just type in Desmos, D-E-S-M-O-S, and it's usually the first item that appears on your search. And then you're gonna just click on the first item. It's like the item to click on. And we're gonna type in our function, which I have written down right here, negative x squared plus 3. Now it actually says y equals, oops, negative x squared plus 3, but it didn't really change much to add the y in there, because all functions are usually solved for y. But at least now we can see what we're looking at. Now what we have here is a window. The window is as much as you can see. All right, so just like the window of a house or something, I can kind of move it and look around at other things. And you notice that this line keeps going to the left, going to the left, going to the left. And if I go over here, it's going to the right, to the right, to the right. And it goes on forever, right? Any number that if I keep going down and down, I'm just gonna get more and more numbers. Right now I'm at negative 250, and I could go down even more and faster, right? I end up going down further and further. So we know the domain for this one, but what about the range? Okay, I'm gonna push the house button. When you click on this house button, it takes you back to a centered view. So that way you can see what you're looking at. You can also, again, move this around. If you don't see anything when you type something in, make sure you have the equation correct, or look around up or down, because your function may be out of the view of the window. Anyway, so hopefully we have everything we need. Last thing is, oh, sorry, the range in this case here is, if I'm moving from left to right, you notice that we go up this line, up, up, up. We reach a peak, and then we go back down. So we reach a maximum, and the highest y value is going to be 3. So to fill this out, our domain is all real numbers. But the range is going to be, well, okay, so 3 was the highest number we could pick. So y has to be less than. All right, make sure you got it right. So if it's this way, that means greater than, because the mouth is open towards the y. This way means less than, because it's open away from the y. So there you go, like they say, the mouth wants to eat the bigger number. If the y was the bigger number, because again, we don't know what y is, or y could be anything under 3, but that's how we would write it. So 3 has to be bigger than y was one way you could read that. And is this a function? Well, again, we had this kind of shape called a parabola, and if you were to run a vertical line through it, it would not cross more than once. So this is indeed a function, so yes. Now on to number 12, and I'm going to go back over there. So let's see, negative 5x minus 1. Negative 5x minus 1. So I'm going to go ahead and push that in there. And again, these lines go on and on forever in both directions. Okay, I could be here all day showing you where this line is going, but I got better things to do today. So keep that in mind, because tomorrow we're going to be doing some graphing, and you got to keep in mind that these lines move on in both directions forever. And if we're looking at the domain, so to help you picture domain, I'm going to put in a vertical line. So imagine my vertical line like this. See, I'm going to pass this vertical line. And you can't really tell, but it's crossing along the top. And you can see that it passes my red line. And it keeps going so, and it keeps going on forever. So in that case, because we have a straight line, it never crosses more than once. So the answer to that one will be yes, it is a function. So for this one, we have all reals, and the range is also all reals. And for function, yes, it's going to be a function. All right, that one was a pretty easy one. And most lines are going to be functions. Most straight lines are going to be functions. Now, when we say line, we mean that it has to be a straight line. If it's not a straight line, we'll usually use a different word like curve or parabola or hyperbola or something else like that. But yeah, when people say line, you got to think it's going to be a straight line. And let's go ahead and go back there and type in y equals -7. So y equals -7. All right, so where is it? Well, like I said, sometimes you got to move the window around. So I'm going to scroll out, and that's going to zoom out. And you can see right there that we have a horizontal line, a straight sideways line, starting at -7. Now, okay, so you're in Algebra 2 now, so you definitely took Algebra 1 and geometry. You might remember the y equals mx plus b. In this case, we are missing the x. If a function or a linear function has no x, then that means it will not cross the x-axis. So if I keep going sideways, it stays the same distance away, same distance, same distance, same distance, does not change. But again, if I pass the vertical line through it, no change. Never touches more than once. So in this case, this one will be, yes, it is a function. So let's go ahead and start filling out what we know from the graph. So the domain in this case would be all real numbers or all reals. Means the same thing, just a different way of writing it. And the range is a different one because we only have one possible value that y can be. Let me just go back over there really quick. See, I have an intersection here at -10. -10 is 7. If I move it to 0, still 0, -7. If I move it to +10, the y value is still -7. It doesn't change. It's always going to be -7. So y equals -7. And function or not? Yes. All right, let's go ahead and do this last one. X equals -1. So type that into our graphing tool. X equals -1. There we go. So we have a line here at -1. And we have only one possible domain. The x value for this line, since it's only perfectly straight up and down, we can only have one value for it, and that is -1. That's the only number x can be. Y, however, can be all real numbers because if I keep going up, there is a value for y that I can put in there to get -1. But if I were to pass the vertical line test to see whether it's a function or not, I run into a problem right here because at this point, both lines overlap. And that means that there is a repeat of x values. So this one is not going to be a function. It fails the vertical line test. So let's go ahead and go to filling out the domain. So in this case, the domain is x equals -1. That's the only value we can pick. And range, in this case, here we can go with all real numbers again. All right. Going into the next part here, so this is going to be the next page, is more function relations. So here I have function notation, and basically to really simplify it, we replace x with f of x. So where we might say y equals 2x plus 7, to put it in function notation, all we got to do is take out the y, so take out the y and replace it with f of x. Now it's a function. What used to be just a line graph is now a function, and how you would read that is input to output. So like I was telling you earlier, ordering a cheeseburger is you're telling the person what you want. So if you've ever, well, I'm sure nearly all of you have been to a restaurant, but if you remember being at the restaurant, you tell them what you want and they tell you what to pay. Obviously, the more things you buy, the more things that you will have to, the more money you will have to pay. So you are the input and the price is the output.
Mr. Nance?
Yeah.
We only see your decimals, your graph still.
Darn. Okay, I forgot to change the share.
Thank you.
All right, so there we go. Yeah, I wish it could follow me on the screens. But anyway, y equals 2x plus 7, and you would just replace that with f of x is negative 2 plus 7. So everything just stays the same. You just take out y and replace it with x. And again, x is the input and y is the output. That's the result. Function notation is useful for finding a value for a certain domain. And I think it's easier to show that. So I'm going to wait till we get some examples before I begin evaluating the functions. So to evaluate them, you're going to plug in the number they tell you to use. So in this case here, they say f of negative 9. And the directions say to use these for f and g functions. So f of negative 9, so this is telling me f of negative 9, it means take your function f and plug in 9 everywhere you see x. So negative 5, there's x, minus 14. Okay, now I am going to need to put in negative 9 and evaluate it. So negative 9 times negative 5 is going to be 45 minus 14. And this is going to be, let's see, 41, 31. So 31 is the result. So the way you would read this is f of negative 9, or the function at negative 9, is 31. So if I put in negative 9, I get back 31. So again, there's an input-output machine. So again, all machines have a function. If you put something in a refrigerator, it will get colder. All right, if you put bread in a working toaster, you will get toast. That is the function of those machines. You have an input and you get an output. All right, so f of 3/10. So I'm going to go ahead and put in negative 5 and plug in. I'm just going to use the same thing. So negative 5 times, take out the x and put in 3/10 minus 14. So to multiply these together, top number times top number. So that's 15 times, I'm sorry, 5 times 3 is 15. I'm already getting ahead of myself. 15 over 10 minus 14. So don't forget the negative here. So that number is still going to be negative. And 15 over 10, if you have a calculator, that just comes out to 1.5. So 1.5, and that's negative 1.5, is going to be negative 1.5 minus 14, so that's going to be 15.5. Now, I don't have a whole lot of space to work in here, so I'm going to go ahead and just kind of skip that last step where I turn into decimal notation. But again, if you have a calculator, go ahead and just, I think most of these will get a number, so they won't have too many numbers that are repeating numbers. All right, so let's go ahead and do G of 0.4. So G of 0.4, plug in negative 0.4 in there. Now there's a negative already with the function, so you don't need to worry too much about, oops, that 9 needs, the 9 with the X needs to be replaced with a 0.4 minus 1. And then from here, we're going to have to evaluate it at 0.4. So if I were to multiply 0.4 times 0.4, I would get 0.16 times, and then 9.04 would be 3.6 minus 1. Okay, my handwriting, I'm trying to write really small. So I'm going to put these together, and I get negative 3.6 minus 0.16, and that would be 3.44 minus 1. Whew, getting a little tongue-tied there. And this is 1.0, so if you don't see a decimal, all right, I see students do this all the time. They might put something like 3.43. Okay, but again, you gotta make sure your decimal point lines up. Keep track of your place values. So G at 0.4 is equal to 2.44. And there you go. I'm gonna box that up so that way we know it's the answer. And let's get to number 4. So I'm gonna plug in to the function G, -7. So use your function G and punch in -7. So this one was kind of a tricky one because there's a negative already with the function, but then the 7 brings its own negative with it. So you end up with 2 of them. Now, how you use this, there's a little bit of know-how that goes behind this one here. Now, pay attention to this one because this is a tricky one, because I'll get some people who will say, wait a minute, isn't negative times, if you square it, isn't that going to be a positive? Which is true. -7 times -7 is positive 49, but this negative on the outside is not affected by the square. That number didn't get squared, only what's in the parenthesis got squared. So this negative is still there, and it jumps onto the 49. Now in this case here, I get negative 9 times 7, which is 63, minus 1. And it looks like they're all negative. So I'm just going to put all those negatives together. So P of -7. So again, P, what am I talking about? I said G, I needed to say G. G of -7. When I put in -7, the number I get out is 113. So again, input is -7, output is -113. There you go. So again, function is literally kind of means the same thing when you think about it. It's like something's job, you do something, like you buy something and it does something for you, A shovel's function is to move dirt. Your gas pedal has a function. In a vehicle, the harder you press the gas pedal, the more acceleration you will get. Okay, so let's go ahead and work on this one. Now this one's a double function. I have a function within a function. So I think I confused a few people this morning with this one. So I'm gonna color code this one as green and color code that one as orange. So first off, I'm gonna evaluate the function f of 1. So -5x, but instead of x, I'm going to put 1 in there. minus 14. So negative 5 times 1 is going to be negative 5. Negative 5 minus 14 is negative 19. There you go. Now I'm going to evaluate the function of f at negative 4. So I'm going to plug into my function here, negative 4. So negative 5, but instead of x, negative 4 goes in there, minus 14. Now again, take care of your order of operations. Multiply first, so negative times negative is positive. 5 times 4 is 20, so positive 20 minus 14. Okay, 20 minus 14, that's pretty easy. Let's go with 6. Now be careful, because this is where I think I lost a few people. This negative is still here. So this is negative 19 minus 6. Now, if you minus a positive number, it's just like saying negative 19 and negative 6. They will combine to make a bigger number. So in this case here, my final answer is negative 25. So sometimes you have to do an operation with the function and then do it again. Now, another thing, I always take time to point this out because I will always run into people that make this mistake. We are not solving these problems, we are evaluating them. Okay, so solving means you are trying to get the variable by itself. Evaluating means that you're taking care of operations or simplifying something, all right? So in this case, evaluating means we substitute something and then we see what we get out of it. So again, from all grades, so freshmen to college level will always say solve, solve, solve. No, you're not solving every single problem. Solve is not just, it doesn't mean do something, okay? Solve means to put something into an algebraic equation that works. All right, so sorry about that. But you needed to hear it. G of 12. So let's go ahead and put 12 in there. Now this means to double the function g of 12. So g of 12, I'm gonna go ahead and put that into my, make sure you put the parentheses in the right place, because if I did not put those parentheses in there, that might have meant that it would be negative 12 times negative 12. But since the negative is on the outside, so again, put parentheses around the x, then take out the x and put in 12. All right. So again, don't put the negative in there with it because it doesn't belong in there. 9 times 12 and minus 1. Okay, so 12 squared, I know that one. 12 times 12 is 144. But again, that negative on the outside is not affected, did not change anything. 12 times 9 is 108. And from here, I still have to do my order of operations. I could work left to right, but what I'm gonna do is I'm gonna put the two negative numbers together, so we get negative 144 minus 1, which is negative 145, and negative 145 minus 108, in this case, would be negative 74 is our final answer on this one. And if you're not sure, you can always just use your best buddy calculator. Now, this lesson is a little bit longer than my typical one, so I'm gonna decide to just stop it right here, because some of these, like I said, are a little bit tough. If you were in a normal classroom and you were gonna ask for help, I would be right there, you know, in the room to help you with it. But these next examples, I feel like most students would have trouble working on them on their own. So I'm gonna go ahead and take off some of these more difficult examples in the next one. So for the homework, I'm gonna tell, now, okay, I looked it over a little bit more closely, but I think I said from 1 to 13. So for the homework packet, for this particular assignment that is marked linear functions, is it marked linear functions? I think I have the packet right here in front of me. It is called relation and functions. So the assignment is called relation and functions. So just do problems 1 through 13. I think you could do 14 and 15. they're not as tough. We have covered the material you need for those. But the only part that I'm really going to grade is numbers 1 through 13. So if you're watching this or attending the Zoom, you have a benefit. Okay, so for the rest, just put attended the Zoom or watch the video and just go ahead and leave off 14 and 20. And again, they're not really that hard. I'm not trying to downplay anything, but I'm also going to tell you what I told my morning classes, and that is, if you want to, if you feel like you are particularly adventurous or you want to challenge yourself, I'm going to make them extra credit. I'm going to make it like 2-3 points extra credit, because this whole assignment's worth 5 points. So 2 or 3 points is quite a substantial amount of points. But if you don't do them, there's no penalty. So that's probably the choice that I can do that's the most fair. So again, just problems 1 through 13 on relations and functions. That's the first part of the packet. And I think that's going to be it for today. So I'm going to go ahead and go back to this screen here. And if you want any questions or answers or anything like that, I'll go ahead and take those for the next few minutes. But for now, lesson is done. And I will see you tomorrow.